Here's the key to the Unit 2 test Quadratics. We're going to solve every one of these problems and go over how you do it. Alright, first up, we got to factor. We got to factor 4 times, in fact. How do we factor? Well, these are all the easy type. How do I know they're easy? Because there's no coefficient here in front of the x. See, if you had a 2 or a 3 there, you get into harder territory. But if it's nothing, or as we say, it's implied to just be 1, then this is a real easy type. We can kind of do it with this thing called the x method. We draw a big X like this. We put the constant term, so this number, with its sign included, by the way, positive 8, up here. And we put the coefficient of x, not x squared, that's just 1, but the coefficient of x, the negative 6, down here. And then we got to come up with 2 numbers, which we'll put here and here, which multiply up to the 8, but they got to add down to this, well, negative 6. So you got to come up with these numbers. You got to know your times tables, but this should be pretty easy. What multiplies to 8? Start with that. Well, you can do 8 times 1. That's always a possibility. Just the number in 1. And then, let's see, going down from there. 4 and 2, maybe? Does 4 times 2 make 8? Sure does. Would 4 and 2 make 6? Well, yes, they would. Now, 4 and 2 would make positive 6, and I need a negative 6. So what do I do? Well, if I made them both negative, well, then a negative plus a negative would be a greater negative, negative 6. But a negative times a negative is a positive 8. So this works. So am I done? Almost. So a trinomial quadratic, basically a degree 2, or an expression which has a little square in there somewhere, and it has 3 terms like this, it is going to always factor into 2 binomials, two-term expressions. And since this is the easy type, I know that the first term of each of the binomials will both be x. It's because x times x will become x squared. So all we were really solving for were the 2 constant terms in the binomials, which would go here and here. The order doesn't actually matter as to which one goes left or right, but that right there would be your factored form of this quadratic. That makes sense. We can do the rest real quick. So draw an x. Let's put the negative 10 up top, because that's the constant term. We'll put the positive 3 down here. We'll play the same little game. What multiplies up to 3 but adds to 10? Sorry, what multiplies up to 10, and adds to 3? And the result we're going to put in this same format. It's going to be x and x, and we're just figuring out the 2 numbers that go here and here. So what multiplies to 10? Well, again, you got 10 and 1, but 10 and 1 don't make 3. What about 5 and 2? That would work, right? 2 and 5. Now, should I make them both negative like last time? Or both positive? Well, 2 plus 5 is 7. How is 2 and 5 going to make 3? Well, if you made one of these negative and one of these positive, you could end up with them taking the difference, right? If you add, say, negative 2 to positive 5, that takes the difference and would get you a positive 3. Yet a negative 2 times a positive 5 would be a negative 10. So those are the 2 numbers that work. Negative 2 and positive 5. There we go. One more. I want to say one more. 2 more to go. Put the positive 5 up here. Put the negative 6 down here. What times what multiplies to 5 and adds to 6? I know I saw in the test several people kind of get this one backwards. It's tempting to get it backwards. 3 times 2 is 6, that's true, and 3 plus 2 is 5, that's also true. But we are trying to multiply to 5 and add to 6. So what multiplies to 5? There's actually only, I should say, 2 numbers that do it. 1 and 5. So we know it has to be 1 times 5. Now if I need 1 times 5 to make a 6, 1 plus 5 does make 6. But to get a negative 6, well, just like the first problem, I'll make them both negative. Negative 1 times negative 5 is positive 5, because a negative times negative is a positive. But a negative 5 plus a negative 1 is a negative 6. So we'll plug in those numbers like this. And there's our number 3. One more on this page now. So we got the x method, we got 22, and we got 13. So it multiplies at 22 and adds to 13. Always start, like I said, with the number and 1. 22 times 1, 22 and 1, that makes 23. Maybe if you subtract 22 and 1, you can get 21, but you're not going to get 13. So what's next? Try dividing it by 2. So 2 times what is 22? 2 times 11. Would 2 and 11 make 13? Yeah, 100% would, right? 2 plus 11 is 13. Make them both positive to get to be a positive 13. And yet a positive times positive is still a positive. So positive 2 and positive 11. And that's the first page. So now we've got 3 problems on finding the zeros. Now, 2 of these can easily be done with factoring like the previous page. One of them would probably be better done with the quadratic formula, which is this guy. So we'll use it later. All right, for these 2, same as the previous page, we are just going to draw our x, put the 30 here, the 11 here. What multiplies to 30 but adds to 11? Hopefully you can figure out that it's 5 and 6, both positive. And then we can put this into the factored form. X plus 5 and x plus 6. The difference here is, now instead of just being done, we have these equal to 0. And we can just set each of these individual factors equal to 0 to get the actual, quote-unquote, zeros. These solve real easily. U minus 5 minus 5. This will be x equals negative 5 as our first 0. And U minus 6 minus 6. This will be x equals negative 6 as our second 0. And those are the 2 solutions for this one. This one works the same way. It's 32 and 12. What multiplies to 32 adds to 12? Probably an 8 and a 4. Both positive again. Same setup. X plus 4. X plus 8. The idea is that they're equal to 0, so whatever makes this 0, whatever makes this 0 will be the zeros. Another way to phrase this, since I'm writing out x plus 4 equals 0 and x plus 8 equals 0, is just to ask what x value, when plugged in for this term right here, would cause this term to be 0. And the answer to that is going to be negative 4. Same way, what makes this equal to 0? Negative 8. Those are those 2 solutions. The best way to do it will be by using the quadratic formula. As long as you can identify what the A, B, and C are and plug it into this formula, you can just print the answer on the calculator. So plugging this in, you'll have negative 13 plus or minus the square root of 13 squared minus 4 times 2 times 20 all over 2 times 2. Now if you compute this with a calculator, it's just going to print out the 2 answers, namely negative 4 and negative 5 halves. This is done by either using the plus or the minus. Okay, so now onto the third page. Now I've got 2 problems where we have to evaluate these functions at a particular number, and we'll have 2 problems where we'll have to find the vertex of the parabola, or of these quadratics. Now, the idea here is that these at least help you be prepared for these, because when you find the vertex, you have to use this formula, the axis of symmetry. That will get you a number, an x value, which you'll then need to just plug in for these x values. And that gets you the y coordinate of the vertex. The vertex is an xy point. So I'm going to show you how to do these. They're simple enough, but just bear in mind, this skill ties directly into these. Okay, so what do you do for this? Well, this is really about understanding notation. If I say f of x is equal to x squared minus 9x, this x is the input of the function. So if I say f of 0, I'm going to write the same function, but instead of an x in all the places I see x's, I put a 0. So I quite literally can write 0 squared minus 9, and there's implied times there, 0 plus 20. And then I just evaluate this. I see what this is by crunching all the numbers. You can do it in a calculator, but 0 squared, 0 times 0. 9 times 0 is also 0. So this whole thing right here is just 0. And then you just have a plus 20, so it's just 20. For this one, there's at least a number that's not 0, so it's the same thing though. I put in the 3 for each of these x's. So this becomes 3 squared plus 3 times 3 minus 10. Same deal, plug into a calculator, but 3 squared is 9, 3 times 3 is 9, so 9 plus 9 would be 18. Then you minus the 10, and 18 minus 10 is 8. So, simple enough, that's how you evaluate a function. Now for these, I'm going to need to do more than evaluate the function. I'm going to need to use this formula and then plug it back into the function to evaluate it. So let's see how that goes. First of all, you got to know what A and B are. They're the same as the previous page. That's A, that's B. This one is C, but I don't really need to identify that for this problem. So the formula goes x equals negative, so it's the opposite sign of whatever the B is, so negative 12 over 2, that's just this 2, times the A, which is also 2, so over 2 times 2. So we can compute what this is. Negative 12 over 2 times 2, that's negative 12 over 4, which is negative 3. So now that we have this negative 3, what we're going to do is we're going to plug it back in for x. We're going to evaluate this function with negative 3 as x, and that's going to give us the y coordinate of the vertex. So we're going to do 2, oops, wrong button. We're going to do 2 times negative 3 squared. These parentheses are very helpful to put in whenever you're putting in a negative. Keeps the calculator from making an error and also helps keep things clear for us. Then plus 12 times negative 3 and then plus 16. And then we compute this. And again, you could plug into a calculator, but ultimately if you do, you should end up getting negative 2. And this sort of is the solution. Of course, the vertex is a coordinate point, so we could finally write that as negative 3, comma, negative 2. That is the x, and that is the y coordinate of the vertex. All right, just one more of this type, though. Real fast, the a in this case is the implied number 1, and the b is the negative number negative 8. So this negative applies to the b. So I'm going to do this kind of in a more crunched version. I do negative 8 over 2 times 1. That's going to be a double negative positive 8 over 2, which is a 4, and that'll be my x. That 4 I'm going to plug in to the equation, so I'll have 4 squared minus 8 times 4 plus 15. And this should compute, I believe, to just be, it was either positive or negative 1. Let's see. This will be negative 32, this will be 15, and this will be 16. Well, I know 16 plus 15 would be 31, so yeah, negative 32 and a 31, this will be negative 1. And so the coordinate point is both the x coordinate, so 4, and the y coordinate, so negative 1. And that's the vertex there. All right, last page. We've got a combine like terms, or simplifying two complex numbers, And then another one, we find the zeros, but we're going to have complex solutions. The solutions will be of this form of a complex number. Let's do the complex numbers one first. They're actually pretty easy, as long as you understand that you just combine like terms. So numbers with numbers, and then I terms with I terms. These are these imaginary parts combined. So this just becomes whatever 7 plus -2 is, and then separately whatever 9 plus, this would be -8 is. These terms though, of course, have the I. I'm going to write the I on the outside. You can think of this as 9i plus -8i, but you just combine the coefficients and then the I gets kind of slapped on the end. So 7 plus -2, that'll be a difference. So you'll get 5. And then 9 plus -8, that's again another difference. You'll get 1. So 1i, which I could just write as I. So 5 plus I, 5 plus 1i. Same with this. 6, but this is now -4. And you could write this as just 6 minus 4, but you just need to make sure that that minus applies to this -8 as well as to the 4. So what I mean by that is when we have this -5i and we're minusing it from the -8i, that's a -5 minus a -8. And that will determine your I term. One common thing we do in math is we do a plus a positive when we have a double negative like that. So this is basically -5 plus 8, which the difference of 5 and 8 then is 3. So it comes out as a 3i. And then of course 6 minus 2 is more straightforward. That's just 2. So it's 2 plus a 3i. Ends up being a positive 3i. Alright, so last part. And this might be the most complex of all of them. Not just because the solutions are complex, but because we can't just fully plug this into a calculator like we could do back in the second page. We're going to solve this with the good old quadratic formula, but it can only, well, it will take us all the way, but we will just have to kind of manually evaluate this, which is good. I get to show that. First part, of course, is identifying the A, B, and C. So A is the implied 1, B is 4, C is 5. Plugging into this formula, let's write this down as -4 plus or minus the square root of 4 squared minus 4, that's the 4 from the formula, times 1, that's the A, times 5. And the whole thing is over 2 times 1. Again, that's the A. All right, now if you were to plug this into a calculator, instead of just printing the answer, what's going to happen is you're going to get an error. So what gives? What's happening here is this inside bit, what we call the discriminant, it's going to come out as a negative. Watch, what's 4 squared? That's 16. What's 4 times 1 times 5? That's 20. What is 16 minus 20? Well, that would be a -4. And if you try to take the square root of a negative number, it's impossible. It's one of the rules of math. It's because you can't have a number multiplied by itself come out as a negative. So what do? Well, the thing that we learned is we treat negative square roots as we'll put in an I term and then treat the rest of the square root as just positive. So we can think of this negative root 4 as I and then root positive 4. Which we can take the square root of. The square root of 4 is just 2. So this can become 2i, or I2. We'll write it as 2i. Now calculator, at least most calculators, won't do that for you. It'll just say error. So we are going to write the 2i. And so what I'm going to do is I'm going to have to simplify the rest of this myself. It's not too hard, but -4 plus or minus, and now this whole square root turns into 2i. Now it's all over 2 times 1, which is 2. And so this is sort of correct. I accept this is correct, but you could do one more thing. You could simplify this. You can divide the 4 and the 2 by 2. So if you divide the 4 by 2, it's a -4. It becomes -2. If you divide the 2 by 2, it becomes 1. So you just have the I left. And so you could simplify this to just be -2 plus or minus I. This technically means it's -2 plus I and -2 minus I, but this is a nice shorthand way of writing it. So there you go.